So today, class, we're going to learn about chi-square. Does anybody know what chi-square is? Liz?
To determine whether experimentally obtained data constitutes a satisfactory approximation of an expected ratio.
A good scientific answer. Now, in layman's terms, it means to determine whether it is reasonable to attribute deviations strictly due to chance. So in your experiment, whether your outcome is due to chance alone. Now, the equation for chi-squared is where this equals the summation. So does anyone know what this means, what this stands for? Emmanuel.
O stands for observed and E stands for expected, and these are the values of the experiment.
That is right. So the agreed upon arbitrary limit of your values being due to chance alone is 0.05. This means that you have a 5% chance or greater that your values are due to chance alone. If it is less than this number, that means you have less than a 5% chance that your values are due to chance alone. This is not accepted. This is equated to 1/20, which equals 5%. Now when we do an experiment, like in today's experiment of C. elegans, we have our normal worms and we have our uncoordinated worms, which we call UNC. Now to determine what the expected values are going to be, we use the Punnett square. Of two heterozygous N2 worms. Filling out the square, we get a ratio of 3 to 1, which translates to 75% and 25%. Now to move this into our table, our total that we received of our observed worms, which were 102 normal worms and 44 uncoordinated worms, is 146. We use this value to determine 75% of 146, which is our expected value, which is 109.5. And we use 25% of our total to determine this value, which is 36.5. And to make sure our math is correct and that everything equals out, our total is also 146. We subtract E from O. And then we square the values. So then we take our square value and we divide it by our expected value. So then due to our formula, we have to sum these two values, which gives us a total of 2.0548. Now when we get this value and we examine our table, do you think we can accept or reject the number? Anybody? Chi-Chi.
Rejected.
Why do you say that?
Because it doesn't fall between 0.2 and 0.05 on the chart.
And are you using degrees of freedom 1 or degrees of freedom 2?
2, because there's 2, right?
That is incorrect. When calculating degrees of freedom, the formula that you use is n minus 1, where n is the number of phenotypes that you are observing. Here we are observing 2 phenotypes. Our formula becomes 2 minus 1, which then equals 1. Now does this change your answer?
Yes, it falls between 0.2 and 0.05.
That is correct. So we can accept our unworms. Alright. Okay, so does anyone have any questions? Emmanuel?
How do you determine if a value is rejected?
That's a good question. So say we had an x squared value of 15.01 after our calculations. If our n equals 6, that means that our degrees of freedom, n minus 1, equals 5. So looking at your table, you can tell that that value falls outside of the required limit, which is lower than 0.05, and you would reject that value. So do we have any more questions?
No.
No.
Good job today, guys.
Yay!